Hi, this is the result of my project to improve a video terminal, an RS-232 terminal that I purchased as a kit in the late 80s. It's called the Linger Enterprises 65/9028. It was published in Microcornucopia in issue number 23 a long time ago, and it was typical of something you would see at the time, which were these kits to replicate a VT100 or VT52 or some other terminal. I used it for a number of years, attached to a OS9 computer system, used it as my main terminal for a while since I had a nice keyboard and so forth for it. I recently pulled it back out, and it's a fairly capable board. However, it did suffer from basically being a remnant of the 80s. If we look at the schematic here, it is a 6502 processor board, a fairly straightforward design, with up to 8K of RAM, I think 16K of ROM. It's got a 6522 VIA on it for talking to a PC keyboard, PC XT, not an AT, and a 6850 UART on it, with some fun little logic over here for faking out having a second serial port to talk to a printer. Stuff I don't really use. The heart of the design, as far as the video output, is a CRT 9028. There's an option for a 9128, which is what I believe I have in my system. This all works fairly well. However, like I said, it had issues on more modern systems because its maximum baud rate was 19200. It's clocking at 1.8432 megahertz, which you'll recognize is a nice number that can be divided down to common baud rates. But it can do much more, and I'll show the results of what I did with that by modifying the hardware a little bit and also modifying the firmware. Okay, so this is my 65/9028. As you can see, here's the processor, the 6522, the 6850, and then down here's the CRT 9128, which does all the business of the display. This is some old cache RAM from a 486, and then a EEPROM, which is a little bit faster and easier to program. This is the output on a old CRT I bought. Okay, let's talk a little bit about a test method for how to evaluate the performance of this terminal. One of the longest commands of modern day Linux is to type dmessage and watch its output scroll. If you have a terminal, that can take quite a while, as you can see here. This is at 19200 baud with the stock firmware. There's just a lot of garbage on here, and dmessage has gotten very full of output in modern Linux systems. So I decided that was a good way to determine the performance of the terminal and measure the number of characters that can be displayed in a typical dmessage output per second as a test methodology. Okay, so this shows the output in 4 different configurations. The original firmware at 19200 baud, the original firmware with the hardware modified for 115-200 baud, a replacement firmware that I wrote in C in the CC65 compiler at 115-200, and then also with the clock rate bumped up. All of these show a big improvement, up to 121% faster. Now, this works great. I've since actually improved the firmware even a bit more, and you'll see that in the video now, where we're getting about 8,000 characters per second, which is right at 4 times the original speed. Now, this is at double the clock rate. That's why the processor is replaced with a modern 6502, which is rated for 10 megahertz, but I was able to get 3.6864 out of it. A modern 6522. And in general, just improving the firmware. It's no longer burdened by having to emulate a number of different terminals. I can just emulate the VT100 that we all know and love. Okay, so now that we've seen how the firmware performs, I think it's worth a little bit of discussion about why I decided to do this. The terminal is a fairly simple terminal. The CRT 9028, 9128 is a fairly simple VTLC, as they call it here, but basically just a video generator. It uses a fairly simplistic by video standards um, set of registers to allow you to basically just be a video terminal with some limitations. Like, it's not a very good choice for, say, a VT100 emulator because it can only do, say, one attribute at a time because it uses an extra bit in the video RAM for that attribute. However, it is very simple to interface to the 6502, and at the time was very cost effective, so that was what made it a good choice. Some other aspects of the original firmware of the Linger I thought could use some improvement. Number one, the thing that just drove me nuts for years was that it did not emulate the VT100 up, down, left, right, and arrow keys. It sent, I think, the standard keys that were used for Dynastar at the time, or WordStar, which was great in those programs, but it was kind of useless in most other things. Additionally, the VT100 emulation was not ideal. It did not do the wraparound at the end of the line quite right, which caused extra line feeds in the output of programs like Top. Obviously, you could write your own term cap entry. That's a little tedious on some systems, but even that suffered from limitations. And like I said before, there was a printer interface that I wasn't using, and some other things. So I chose to re-implement it in C to make it a little simpler. I'll be putting that code up on GitHub shortly because I do find that it could stand the benefit of multiple people looking at it, and also for anyone else who has a Linger terminal, they may find it useful to at least tinker around with. Thought I'd also spend a little bit of time about the hardware modifications. As you saw earlier, I replaced the RAM with some cache RAM stolen from an old computer. That was just to get extra speed. The original part, I think, was a 150 nanosecond part, and I replaced it with, I think, a 25 nanosecond. And the ROM as well. I replaced it with a double EEPROM rated at, I think, 45 nanoseconds, both of which allow a higher clock rate from the processor. I found that the more I pushed it, the more unstable things became, and looking at it on a scope, it seemed that that made a lot of sense to change that. I found the CRT 9128 actually seemed to be able to run quite a bit faster than its rated speed, so didn't really have to do anything for that. The 6522 I did replace because I can get modern versions rated to higher speeds. I do suspect there's a little bit of signal degradation by the time it gets to that side of the board for the 6522, so there does seem to be a little bit of instability from that, or possibly the 6850. That's also a part that's rated at, I believe, 2 megahertz, and we're now running at 3.6 megahertz, so pushing it a little bit beyond its spec. As far as the change to allow for higher baud rate, the 6850, the transmit and receive clocks are driven in the base design from PB7 of the 6522, and those of you that have used the 6522 know that you can program that to basically be a clock divider. However, that does limit the maximum speed to, in the default configuration, to 19200 baud, based on a 1.84 megahertz clock. Since I've doubled the clock, basically I can now get 3.6864 megahertz. This schematic, by the way, says 1.8432. The board I have actually has 3.6864. That's divided in half by the 7473 here. What I did was actually modify this by actually lifting the pins on the 6850 up and driving those directly from the 1.8432 megahertz output of the 74 LS73. I added a switch on mine, so I can either use a configurable baud rate or just the 115-200, and that seems to work fine. The other modifications I did a number of experiments with the 6502 clock inputs and outputs. If you'll notice on this schematic, which is a little bit different from the actual board I have a later rev of the board. The Phi2 output and so forth are actually generated on this board, fed into an inverter, which I do not see handy, and that goes to a lot of the other parts. I tried changing a couple things on that and seeing, actually this is that inverter right there, changing that to the different phase clock outputs from the 6502. Didn't really find a lot of improvement there. That was all part of the effort to try to increase the clock rate. It turns out a lot of what was causing instability with the higher clock rates was the way that the 65 or the 9128 was being initialized. If you read the datasheet carefully, you have to set a couple registers and then start the operation. And it appears that the original Linger firmware and my first versions of firmware were doing this incorrectly, assuming that just setting the reset register would kick off a reset. You actually have to set the reset register and then tell it to begin the operation. Once I started doing that, it made the firmware a lot more stable.